Hey guys, I was just working on a PCB which I've called the Deluxe 7-minute fuzz. It's a 7-minute fuzz with a whole bunch of mods thrown in. A germanium transistor cyclase mod and a tone control mod and a switch, so you can switch between a resistor and a diode on the feedback loop of the circuit. Just a couple of things like that. And a gain control as well. So it's kind of like a souped up 7-minute fuzz because people like to add those mods, and it's just easier than having to do all this stuff off board. So I've just been working on it. I've got a breadboard down here, and I just sort of was just examining something, and I thought that perhaps you might be sort of interested in this sort of thing. So with a standard 7-minute fuzz, you don't normally get this sort of low output, but because I've added all these extra mods, when you start chopping off some input with the tone control, you start taking down some volume on the input, because when you lower the bass, you lower the frequency content on the input, and that actually lowers the volume of your input signal, and I can show you that on the oscilloscope in a moment. And also when you, I've got a bias control in the cyclase pair as well, so once you start cranking that up, you're going to take a bit more volume off. With the volume control on the output on maximum, it's pretty much at unity, so usually like to have a bit more than unity on the output. On the screen it comes up at about half, but when you hear it in person it sounds about the same as your clean signal. I'm going to show you that actually audibly. First I'll show you on the oscilloscope, then I'll show you audibly what that actually sounds like through the amp. And then I'm going to show you a way that you can increase the output, a very simple way of increasing the output volume, and probably something you've heard a lot about, and I'm going to show you actually visually on the oscilloscope what that actually looks like, that it's not a lie, it actually does happen. So I'll get to that in a moment. So let's have a look first at how it's set up at the moment. So I'll point the camera down so you can see what's going on. So don't be intimidated by this setup if you're not too au fait with electronics. I'll break it down for you quite simply. So I've got a signal coming out of my mobile phone, my sophisticated signal generator. It's a sine wave, which you can see on the oscilloscope here, the red graph, and it's at 100% amplitude, which gives us, this is a 500 millivolt per division, and I've just got it to calculate that for us automatically, so it's 2.56 peak to peak. And then the yellow is the output. I've connected the other probe to the output, and that is around 1 volt. So it's actually around 1.5 volts less on the output than it actually is on the input. And I'm pretty sure I've got everything turned up full. That's the volume. This is, as I was saying before about the tone control, you can see that tone control actually affects the amplitude of the output signal, because it is cutting off bass content. So as I turn that down, you can see that the output is actually lowering. So actually when it's on treble, when it's on full treble, you get 700 millivolts, and when it's on full bass, so allowing treble and bass, you get about 940 millivolts. So you can see it takes off roughly 15% of your input signal. That's why you may notice when you play around with the tone control on your guitar pedals that you notice a volume drop. That's part of the reason. Sorry about the flickering. I think there's a loose connection somewhere here. But we're still getting the general idea. So that's up. The bias control is off, so it's not really having an effect. Yep, that's off. And this is the gain control, which is actually a 20K potentiometer. If you've seen the gain control mod for the 7-minute fuzz, you'd know that that's way too high. It's the only pot I have on hand at the moment that's even near it. So I can almost not even adjust that. As soon as I start to turn it, only, again, 10%, and I almost lose it. Look at that, it's almost a clean signal. So that would probably be on around maybe 2 or 3K, and you can see just the output signal gets cut off because the gain control goes up too high, because it's, as I said, it's 20K. So that's the standard setup pretty much for a 7-minute fuzz with the extra mods. So as you can see, it looks, you're probably thinking it's going to sound a lot, the output's going to be a lot lower than the clean signal, but I'll demonstrate to you now what that actually sounds like. So obviously this is tricky for me to demonstrate because it's coming out of an amp through YouTube, through the camera, through YouTube, etc., and they're probably condensing the volume level, so you probably have to take my word for this. But they are of a very similar volume level, so that's when everything is cranked up. I'm not reducing the output with the gain control or the bias or the tone. Everything's up as full as it will go. So this is with the effect off. Let me just turn that up so you can actually hear it. And with the effect on. So it probably sounds slightly louder on the output. Not sure if that's to do with just the tonal characteristics of the output signal being heavily clipped or not. You can see obviously here it's spending more time at its maximum value, even though its maximum value is lower. So I suppose we could still increase the output because I haven't. This is the absolute best case scenario. Like I said before, if I start playing with tone controls and BIOS, it goes down from there. So it would be good to have a bit of extra headroom. And now this is kind of getting maybe towards the point of the video. So how would you increase the output? There's one very quick and easy way that you can do that, and that is to increase the number of diodes in the feedback loop of the 7-minute fuzz, or you can do that obviously with pretty much any distortion or overdrive that's got diodes for clipping. So you can you can just change the actual diode. So you can change the diode from a if it's a silicon or a germanium, which is even lower forward voltage. You can put in something that's higher, like an LED, or you can put two silicons in series. I say forward voltage, but what do I actually mean, just for those that aren't familiar with this? The diodes have a forward voltage, so it's the voltage that the diode will conduct at, and this voltage is going to have a big impact on what the actual output, the output level of your guitar pedal will have. So as you can see, this is a BAT41. You see the value down there is 0.38 volts. If we do something that's renowned to be a lot more, to have a higher forward voltage, we will find, whoops, if I put them on the right side, that I have it the wrong way around. We will find that my multimeter does not like measuring the forward voltage of a LED. One moment please. So this is when I reach for the peak Atlas, because it's a much more competent measuring device for pretty much everything, including LEDs. So this says it is a nearly 2.8 volts, the forward voltage for an LED. So if we use an LED in that feedback loop, it's going to let a lot more voltage through on the output. So let's first do that in front of the oscilloscope so we can see that result visually, and then we'll put it to the amp and see what the sort of output we get. So actually I didn't have a BAT41, I had a 1N4148, which is approximately 0.52 volts or something like that. So we're changing that to about the same as a BAT41. We're changing that to a blue LED, which as we just saw is about 2.8 volts. And as we can see, the result is quite obvious visually. The output signal is now greater than the input signal at 2.88 volts compared to around about 2.5. So I have, considering that before the output signal was around half the strength of the input signal and it sounded louder, this should be significantly louder, which is good because we can change things like the tone control on the input, as I'm touching right now, and we're still quite loud. The volume control can now go down without much I mean, again, if it's around half If the output signal is around half the size of the input signal and it still sounds louder, you can still see that we have a lot of play with all of these controls. This is the gain control that I'm mucking around with now. That's on full. If I start to lower that, we can get it almost goes clean in some particular settings. It's pretty close, not quite. So anyway, let's have a listen to it on the amp now, and we'll see what it actually. We'll see if there's a significant increase in the volume on the output. So I've actually left the settings the way that they were, that you just saw them at, which was what was I doing? Oh, that's right. The gain control is in a position where the output signal is almost clean. So let's see if that is actually true. If the output signal does sound roughly clean. That's obviously the clean channel first, and then I'll turn the effect on. Not exactly clean, but probably as clean as you're going to hear from a Min Fuzz type of circuit, because they are heavily clipped. So it does sound a lot cleaner than what they usually sound like. Now, if I crank up the gain control, I just noticed the input's very close to that pot. Just moving out of the way there. If I crank up the gain control, wow, that's a very, very apparent volume increase already. Doesn't sound particularly good, but we can get to that in a moment. Oops. Volume has to go down because it's actually deafening me. Not sure if you can see, but that LED is also lighting up as I'm playing. As the signal is going through the diode, it actually lights up as well. The LED, it lights up as well. Now I just want to check that bias control. Also, I can't remember if I actually left it in the right spot. The bias was in the spot that I was thinking of, which is basically it was off. Once you start adding the bias control on, you start to lose volume again. So it was maximum volume across the board. It was very loud, much louder than the input signal, as you probably may not have heard through the video because it's kind of hard to tell. All you're going to hear is a clipping microphone probably, but I can tell you sitting in front of it, it was like to the ear, it was probably like maybe 4 times louder than the clean signal. But as you may have also noticed, it doesn't sound very good. The LED, I think it's probably letting too much voltage. It's probably not, kind of sounds like it's either clipping too hard or too harshly. So I'd probably experiment with the bias control first. I didn't have much time to play around with that to see if I could correct that. Or, of course, you could just use 2 BAT41s in series, and then you'd end up with around 0.7 volts on the output, so you get the nice tone from the BAT41, but you still get a moderately increased output signal. So when I'm recording these videos, I'm always thinking of what to call the video, because often I just hit record and I just start rambling, and then later on I think, what was the video about? Or I have an idea in my head of what I want to actually say, but the actual title needs to be accurate, so you know what you're about to watch. And I have absolutely no idea what I'm going to call this one, so it's going to be probably a very convoluted description. Either way, hope you liked it. Plan to do more of these in-depth videos as time permits. They take a lot longer than some of my other videos. That's why you probably don't see a lot of this sort of stuff. You know, they're just more time consuming, but I think they are more educational. I hope you like it all the same, and thanks for watching.